All right, continuing on here, let me get a share screen going. Back when I showed you Sebastian Legue's Endless Terrain, there was all this business with callbacks and handling all the action callbacks and having this queue that took care of things. And I just want to show you how you might set up a similar paradigm in with the job system. So I have program 1 here that is going to start coroutines on that it gets from program 2 that has a public function in it, start job, that takes the size of the job, the A and the B, the callback, and the name of the job. So when this completes, it's going to execute this unfinished public function here. This is all in Job Simple Sampler that I'll put in the download site. So in program 2, the program that I'm accessing the start job function in, first of all, I must remind you that you have to using Unity jobs, and if you're going to use the burst, you have to using Unity burst. And there's also a mathematics package that is a thread safe mathematics package, as opposed to our mathf package that is not thread safe. And so probe 2 is going to do the following thing. First of all, we want to set up our job, and it's a make work job. It's not doing anything. It has a count, a number of things it's going to execute. And this is not an iJob 4. It's parallel 4. This is just an iJob. So the execute here is empty, and we have a for loop inside this thing. Here's the use of that Unity Mathematics random. I had to put the Unity Mathematics random in here because otherwise it complains that it can't tell the mathf random or the ordinary Unity random from the Unity Mathematics random. And here I'm seeding it. So my array, it's one of these single entity arrays. Remember, I can't get things back and forth out of floats. I can only get things out through native arrays. So this is a doubly nested loop to do a lot of busy work. It takes the square root A plus B, and it adds the next random number from this random function. That's the setup of my job. Now this start job function, which is the job that I'm calling from my program 1, I'm calling start job with the count, the A and the B, and the callback that I'm going to execute when that job is completed. So in start job, I've got count A, B, the action that I'm going to execute in the callback, and the job name here that's going to appear in the callback when I execute it. So I'm going to schedule it. I'm going to schedule the job. I'm now going to spin here on whether it is completed or not. This is another test that you can use to test to see if the job is completed. And I'll just yield return null. So this is doing not much work, just every frame going around again. When it completes, when the job completes, I'm going to execute that callback, which, as you remember from up here, is unfinished. That's the callback. So it's executing that callback, which is back on program 1, where it's just displaying the answer it got and the job name that was passed in here. And then I, of course, have to dispose of the array. With this kind of thing set up, you can start many parallel jobs from program one. Uh, uh, I believe in program one, the start function is an IEnumerator. It's a coroutine. I'm not sure if this version is or not. No, it's not. If I make that an IEnumerator, then never mind. Uh, I don't need to do that. Coroutines don't block. So this is going to start this job and then start this job and then start this job. And when they're finished, they'll each call unfinished and deposit their results. So after all that, let's see this go. Nothing happens up here. It's all in the console over here with various debug statements. And so I need to not maximize on play. Notice, because I broke that, the native collection has not been deposed, resulting in a memory leak. So that's a bad thing. And so now all 4 jobs are started. Job 4, which is a small job, finished. Job 4 finished first. Job 3, then after that, and jobs 1 and 2 that were the big jobs finished much, much later. So it doesn't matter when they start, the order they start, it's when they finish here that they turn in their results. Now, the other thing that I've got in here just to show you is a sample scene, and this one I do want to maximize. In this sample scene, I have, I think, something like 10,000 entities. And what I'm doing with the job is rotating them. And to make life interesting, they're rotating based on their color. So they have RGB colors that are set with a random color. And I'm using those RGB components of the color to set the Euler angles that I'm rotating them. So, and you can look at the code yourself. And the thing I want to show you here is the profile. So let me go into profiling again. And so now if I run this, first of all, with this collection of 10,000 items, the dominant work being done is the rendering. 47 milliseconds per frame for rendering, 5.49 to 5 something for the scripting. And let me turn off the rendering just so that we can see just the scripting. And let me go down here and again press A so that this expands out. The jobs are kind of idle here. They're doing some stuff, but they're not doing any of our stuff. And so over here, if I press L, it goes into parallel no burst. Now, immediately what you saw is that the scripting after the initial setup went down a lot, now down to 1.5, 1.6 milliseconds. And the job threads are busy doing stuff. And now if I press this one more time, it goes to the burst. And again, the scripting effort goes down now to 0.8 something, 0.5, 0.7 milliseconds. The jobs are, again, idle most of the time. And again, remember, the primary cost and the thing that's really setting our frame rate is the rendering that's going on here, not the scripting. Back to sequential, back to parallel with no burst, and back to parallel with burst, just to show you the things you can do. So I'm going to, Job Simple Sampler also has examples from iJob Parallel 4, breaks a long for loop up, each of which processes on a different thread with iJob Parallel 4 transform. that can affect the position, rotation, and scale. And in the example I showed you, it affected the rotation. There's some other examples there you can have a look at. So I'll stop sharing there and I'll end recording. And this kind of closes out what we're going to do with threads. So I'll see you all in class with parallel programming. Bye.